Good evening, friends. So, this is our last class of this semester. So, we will proceed the last topic that we had discussed of this chapter, that is characteristics of six pulse converter. We will study about the characteristics of six pulse converter. Then there we will see the value of mu, that the range of value of mu, which lies from what is the range of value of mu, then gamma, and then delta. Okay. That is the main function. Wait, let me take you that page. These things we have already studied, so I'm skipping these topics. These topics are already been completed in the previous classes. As you have seen, this is the formula for your harmonics in the diode voltage, that is due to the overlap. What is the formula? Then that was the formula P upon PD naught, that is related to 1 upon root 2 within the bracket f square plus g square minus 2 fg cos 2 alpha plus mu to the power half, where f and g have different terminology, where f is represented by this value cos h plus 1 u by 2 divided by h plus 1, and g is given as cos h minus 1 u upon 2 divided by h minus 1. Okay. So these are the topics that we have already discussed in the previous classes. Then we have also seen the component of the currents that is flowing in the initial condition, how this component of the current is flowing. Then the value of A we had find, that is the direct current. That current is given by ID. Then I is the sine alpha plus 60 degree. That those are the components that we have discussed. Today we had the topic characteristics of the six pulse converter. So as you can say, the three volts when operating, then the accumulation or the running point is represented by this red angle. As you can say, the initially ignition angle is, or you can say firing angle is 0. Here the EMF induced is given by EA plus EB divided by 2. Near this graph represents your EC, where the alpha is greater than 60 degree. Okay, that therefore the range of the value is lies from alpha plus mu minus 60 degree to alpha plus 60 degree. Okay, here also you can see the value is remains same. These are the things that we have already discussed. That means if the multiple operation of the valve is conducted, then at which time the value of the EMF induced is taken, that is given by this representation of the graph. Okay. These are the thyristor valves that is operating during this wave. During this the EMF induced. Here you can say mu is greater than 60 degree for that value. This is the actual mode. That is, if mu is greater than 60 degree, then what will be the value? What will be the value? That is given by the conduction of the thyristor that is occurring in the your say 6 pulse converter. So these are some examples that we have discussed, that for alpha equal to 0 and mu equal to 0, then what will be the value? Then what will be the value? Then here you can see when you put alpha equal to 0 degree, mu equal to 90 degree minus 60 degree, that will give you the value 30 degree. A wait. Then analysis of the 6 pulse converter, 6 pulse bridge converter we have seen, that is related between the star to star and star to delta transformer that is connected with the inverter station, and how that inverter station and transformer line voltage phase voltage related is given in these steps. So we have already seen this type of these topics in the previous classes. I'm not going to discuss these whole things. We will directly go to the topic that is characteristics of the 6-pulse converter. So this is the topic that we are going to discuss today. That is the last topic of the HVDC transmission system. This is the characteristics of the 6-pulse converter. Okay. Now there are three modes of the converter station, or the you can say that the study of the characteristics of 6-pulse converter is taken by the three mode. First mode, when mu is less than 60 degree. Second mode is mu is equal to 60 degree. And third mode is when mu is greater than 60 degree. That is 60 degree is your reference value. Less than 60 degree, then it is taken as in first mode. Equal to 60 degree, it is taken at the second mode. And third mode is taken as greater than 60 degree. Then what will happen? So accordingly, if we move to the our first mode value, where mu is greater than less than 60 degree, then the average DC voltage is given by this equation. That is VD equal to VD naught cos alpha minus ID upon 2IS. The derivation of this ID and IS is done in the previous classes or previous chapters. So we should not concentrate on these topics. We should always we should mainly concentrate the what will happen if the mu have less than 60 degree value. That in first mode value, when VD equal to VD naught within the bracket cos alpha minus ID upon 2IS, then this will have the value when you take this VD naught in the denominator part, you will get VD upon VD naught equal to cos alpha minus ID upon 2IS. When you convert when you convert this equation in vector analysis form, you will get VD vector equal to cos alpha minus ID, where the value of the vector VD is given as VD upon VD naught, VD upon VD naught, and vector ID is given as ID upon 2IS. ID upon 2IS. That is the vector representation. Now, from first equation, as it is written here, from first in this voltage and current are linear. So for different value alpha, the VD characteristics are linear. As you can say this, if you ignore the value of cos alpha, then you can see VD is directly proportional to I2. So if we vary the value of alpha, if we different the value of alpha, then this VD and ID will correlated with linear. That is called linear characteristics. Second mode is when mu is equal to 60 degree. When second mode is when mu equal to 60 degree, where mu is your constant value. Now this is the constant value. So putting the value of mu, you will get VD equal to VD naught upon 2 cos alpha plus mu. Okay. Now from there you will get this is the equation for the voltage, direct DC link voltage. Here you can say ID equal to IS cos alpha minus cos alpha plus mu. ID equal to IS cos alpha minus cos alpha plus mu. From there, you will get the actual value of VD in your vector form. That is VD vector equal to half cos alpha plus mu. Here, the ignition angle and the firing angle is in summation with the cosine angle. So from there, if you solve this equation, you will get VD vector equal to cos alpha plus mu. As you can say, cos A plus cos B divided by 2. So if you write the value, you will get cos alpha plus mu divided by 2 cos mu by 2. That means here you can say you will get a minus, here from there you will get alpha plus mu minus alpha, that will give you the value of only mu. So you can say cos a minus b, here cos a plus b divided by 2, that will be the value. So accordingly the equation 3 has been derived. Now the equation 4, that is current value, is given by sine in terms of your sine, that is sine equal to alpha plus mu divided by 2 multiplied with sine mu upon 2. That is here also, if you convert cos A plus cos B, you will get in terms of your sine in this format, that is sine alpha plus mu divided by 2 into sine mu upon 2. That will give you the equation 4. Now the last one, that is VD, is given by VD. If let us say this alpha mu equal to 60 degree, mu equal to 60 degree. So depending upon the value, you will write the equation VD vector as cos mu upon 2. Cos mu upon 2, that means this value will become 1. This value will become 1. When you put this value, that means alpha plus mu divided by 2, that will be equal to 0 degree. And that from there you will get alpha plus mu equal to 0. If you write the value alpha plus mu equal to 0, that means here we have taken mu equal to 60. That means alpha must have the value minus 60. Then only you will get the value 0 degree. So from there you will get Vd upon, or you can say, if you write this cos alpha plus mu divided by 2 in denominator format, you will get Vd equal to cos alpha plus mu divided by 2. Vd divided by cos alpha plus mu divided by 2 equal to cos mu upon 2. That is the equation. In the similar manner, when you write the equation 4 in the then it will become id vector divided by sine alpha plus mu divided by 2 equal to sine mu upon 2. Okay, from there you will get. So accordingly, if you square the fifth equation and squaring the sixth equation and making the addition of the equation fifth and sixth, you will get this one: cos square mu upon 2 plus sine square mu upon 2. Then you have to square the whole term. This also equation fifth, LHS, and LHS of the sixth equation. There you will get this equation. This the whole equation is named as your seventh equation. So it will give you the, as you can say, this will value of the, this will become 1. And when you write this equation, then only it is called it will give you a equation of elliptical path. It will give you the equation of the elliptical path. Okay, as you can say, 1 equal to Vd vector divided by cos alpha plus mu divided by 2 co whole square plus Id divided by sin alpha plus mu divided by 2 co whole square equal to 1. That will give you the characteristic equation of elliptical. That means at mu equal to 60 degree, or you can say in second mode, the inverter operation is just like a equation give that will equal to your elliptical path. Okay, now the next one is your inverter section. Now from the graph, the commutation margin angle is epsilon naught, and for different envelope angle beta value changes amid hence the extension angle gamma. That means depending upon the value of epsilon naught, if the value of beta changes, the value of extension angle, that is gamma changes. So it will have two modes. That means when mode 1, when mu equal to or greater than 60 degree, that is mu equal to or greater than 60. So in that case, first case is taken as when beta is less than 60 degree. Okay, if the beta is less than 60 degree, for values of mu is less than 60 degree minus epsilon, that will give the gamma naught equal to epsilon naught. And from there, if you put the value of gamma equal to epsilon naught, you will get Vd vector equal to cos gamma naught minus Id vector. That is the linear path that we have discussed. In the previous class, it was your alpha value, that is Vd equal to cos alpha minus Id vector. So here, in the similar manner, you will get Vd vector equal to cos gamma naught minus Id vector. Cos gamma naught minus id vector. In the second similar case, when the beta value lies from between 60 degree to 90 degree, for mu equal to 60 degree minus epsilon naught, then the epsilon naught value will be, here you can say, when you take this epsilon naught, you will get 60 degree minus mu, 60 degree minus mu. So from the graph that we have discussed in the upper portion, you will get that is epsilon naught equal to gamma naught minus beta naught, beta minus 60 degree. That will remain constant because the value of beta lies between 60 to 70 90 degree. And if you place the value, then gamma this will have the constant value. So accordingly, if you write the equation, you will get Vd vector divided by cos mu by 2 plus Id divided by sin square mu by 2 the whole square equal to 1. That will give you the elliptical path. Okay, that is the second case. And the third case of the module 1, what is given as when beta equal to 90 degree to 90 degree plus epsilon naught. 90 degree plus epsilon naught is the range for the beta for this third equation. Now for the value of that value, you will get 60 degree minus epsilon naught, that is less than or equal to mu, and that mu is less than or equal to 60 degree. So accordingly, if you write the equation in the proper format in the voltage equation, you will get Vd vector equal to cos gamma naught minus Id vector. Okay, Vd equal to cos gamma naught minus Id vector. In the similar manner, when you write for the second mode is all about when mu is greater than 60 degree, for beta is greater than 90 degree plus gamma naught. when mod 2 is equal to, when mu equal to greater than 60 degree, for beta greater than 90 degree plus gamma naught, you will get Vd vector equal to root 3 cos gamma naught minus 3 Id vector. Okay, so for this the second mode, this is only the case for the range of the bed, and the equation is given by this, that is vector Vd equal to root 3 cos gamma naught minus 3d. Only the inclusion of 3 and root 3 is the case for your mode 2. Now in the third mode, when mu is greater than 60 degree, then what will happen? Then in the similar case, just when mu is greater than 60 degree, the voltage equation will become Vd equal to Vd naught within the bracket root 3 cos alpha minus 30 degree minus 3id divided by 2is. Okay, so if you write the equation, in the other format, you will get Vd vector. A Vd vector, that means Vd divided by Vd naught. As we have discussed, Vd vector is representation of Vd divided by Vd naught. So accumulatively, we can write Vd vector equal to root 3 cos alpha minus 30 degree minus 3 id vector. Id vector is also representation of id divided by 2is. So that will give you the value of vector id. As Vd and id are linear, the characteristics is linear. As Vd and id are Vd vector and id vector are linear, so the total characteristics of the third mode is also a linear part. Okay, now the equation for this, the whole term of the third mode is given by, here in the y-axis we have taken the Vd vector, that is Vd divided by Vd naught, that is the voltage DC average DC link voltage divided by average DC link voltage is given by in the y-axis direction, and this vector id, that is id divided by 2is, given the x-axis direction. Now accordingly, the position, different position given for different value of alpha and mu. In the starting position at position a, when alpha equal to 0 and mu equal to 0, then this is position a. Then if you move further as the current increases, then the average voltage or the vector DC link voltage will decrease. At this a will become the point p with the decrement, and the value will become beta b equal to alpha equal to 0 to mu equal to 60 degree. Okay, that means alpha remains constant in this case, but the value of mu is increased from 0 degree to 60 degree. In the similar manner, when you put a b, and then it will become c, when c means, or you can say e, we have taken the third component, as you can say this is as c or d, whatever you write, but here we have taken the value, the point is named as e, and for that value, the value of alpha increases from 0 degree to 30 degree, but the value of mu will remain for the value of 60. So in this, so here you can see that a to b, when you move from a to b, the value of alpha will remain constant and the value of mu is changing, but for point b to c, the alpha value changes, but the value of mu equal to 60 degree remain constant. In the similar manner, when e to c move, when you move from e to c, the value of alpha will remain constant, but the value of mu will change. That means double, that means it becomes double. So it will become, for at point e, this is alpha equal to 30 degree, and here you can say alpha is remain 30 degree, but value of mu will is 60 degree here, and here you can see mu equal to 120 degree. Now when you move from c to d, the alpha value will varies, and the mu value will also vary. That means here you can say alpha equal to 30 degree, in the point d, the alpha equal to 15 degree, the mu is 120 degree, and here mu equal to 60 degree. So you can see here the value of a, b, e, c, d, the variation of the alpha and mu is accordingly done in this graph. So for the appropriate value of the alpha and mu, you can see that for point a, when alpha equal to 0, mu equal to 0, the value of id and vd equal to different. That is id value is 0, but the value of vd vector is 1. But for point b, at this point b, the alpha is 0, but the mu is 60 degree. So putting the value of alpha and mu, you will get id vector as 0.25, and the vector vd you will get 0.75. In the similar manner, when you write the for the point c, you will get alpha equal to 30 degree. You can see alpha equal to 30 degree, mu equal to 120 degree. Acha, this is wrong. This point will c, this will become c, this will become d, and this will become e. So accordingly, if you write C equal to 30 degree and 60 degree for alpha and mu, you will get ID, vector ID is root 3 upon 4 and VD is also root 3 upon 4. Okay, and for point D, the value of alpha is 30 degree and value of mu is 120 degree. So accordingly, if you write the value of vector ID, you will get 1 upon root 3 and the value of VD will become 0. In the similar manner, the last point, that is your alpha equal to 15 degree, mu equal to 60 degree, the value of ID will be 1 upon 2 root 2 and the value of VD vector equal to root 3 upon 2 root 2. So these are the some points that is related to mode 2. Okay, so in the similar manner, when you write this equation VDI, you will get VD naught upon 2 for cos alpha plus mu. Now from the graph, from the upper graph that we have discussed, from this graph, you will get this equation, that is beta equal to mu plus gamma, or you can say pi minus alpha. So just put the value of, just putting the value in this equation, you will get VDI equal to VD naught upon 2 cos. Put the value of alpha as pi minus beta. You will get alpha equal to pi minus beta cos pi minus beta plus cos alpha plus mu, that is you will get alpha plus mu, you will get pi minus gamma. So in the similar manner, the value of VD will become VD naught I divided by 2 cos beta plus cos gamma. In the similar, and the value of VD, if you put the value of VD, you will get VDI equal to VD or not cos gamma minus ID upon 2is. In the similar manner, or you can say parallelly, the value of the current, you will get ID equal to IS cos gamma. So normally the value will become, for the value of vector VDI, will become cos gamma minus ID, vector ID for the mode 1. Parallelly, the VDI, vector VDI for the mode 2 is given by root 3 cos gamma minus 3 ID vector, 3 vector ID, that is for the mode 2. So this is the combination of, this is the, as you can see, it is written typical 6 pulse inverter under predictions, constant ignition control, extension angle control, positive and negative direct voltage with respect to transformer with the neutral is given, voltage across valve 1 and commutating voltage is given in the upper graph. Then valve current I1, I3 and I5 is also represented in this figure, and the valve current I2, I4 and I6 is also represented. As you can say, this is the actual performance of the graph. It will start from here, it will become downwards, then again it will move work from this equation, and accordingly it will follow the same process up to the next part. As you can see, this is the blue phase, this is the red phase, this is the yellow phase. Again in the similar manner, three phase working condition is may starts. So in the similar manner, when you write the equation, you will get this equation, that is the converter operating equation for voltage VD and ID are expressed in this formula, that is VD equal to 3 root 2 E upon pi cos alpha plus cos W divided by 2. Now you can see that VD can also be represented by this equation, that is VD naught upon 2 cos alpha plus mu. Okay, so here you can see that VD naught equal to 3 root 2 EL upon pi. VD naught equal to 3 root 2 EL upon pi. This is the line voltage between your transformer and the inverter station. This is the line voltage between your transformer and your inverter station. In the similar manner, the value of the current ID is given by this equation, that is E equal to root 2 omega LC. LC is the inductance of the inductance of the inductor, that is smoother inductor, that is given by this equation, that is ID equal to E upon root 2 omega LC, and the equation is given cos alpha minus cos omega, or you can say cos W. That equation can be also be represented as VD naught divided by 2 cos alpha plus cos omega. Then from there you will get the value of the vector, you will get this idea as this equation. Okay. Now, in the similar manner that we have discussed, it is given the different value of A, B, C. Here, the many number of points is taken, but we have discussed in the previous section in this case. Let me show you. So here you have seen the similar pattern that is given in the book. That is for different value of alpha and mu. And if you plot the value of VD vector and ID vector in the similar manner, you will get A, B, C, D, E for the different value of alpha and mu. Accordingly, the value of VD and ID vector will be occurred. They will be given. So from there you will can see that we can see that for different value of for mode equal mode 2, when mu greater than 60 degree, the value is given as, that is point A, B, C, then F, D, A is given, and for different value of gamma and mu, you will have different value of current, DC line current and DC voltage. Okay, these are the some examples that these are the some examples of the similar pattern. As you can see, it is written. Let me show you. It is written, a grade bridge operates with a delay angle of 15 degree. Delay angle is given as then the leakage reactance of the transformer is 10 ohms. Leakage reactance of the transformer is also given. Then the line to line AC voltage, that is line voltage, is given as 85 kilovolt. Compute the overlap angle and DC voltage for this line current, ID equal to 2000 ampere and ID for 4500 ampere. So here you can see that the solution is given. It is written, a rectifier can operate with when mu is less than 60 degree, or mu equal to 60 degree, or mu equal to greater than 60 degree. That means the operation of the rectifier is of three modes. These three modes are given here. So to determine the operating mode, which we need to know the boundaries of the first two methods. Now we have to calculate the boundaries of the equations. That is, ID1 vector is given a half cos alpha minus cos alpha plus 60 degree, because this is the reference value 60 degree. So we have put it the value of alpha plus mu as mu equal to 60 degree. So accordingly, if you write the value, as you can see, the delay angle is 15 degree. That means this alpha is your 15 degree. So putting the value, you will get cos 15 degree minus 60 plus 15, that will give you cos 75 degree. That is cos 15 degree minus cos 75 degree. You will get the value of is equal to root 2 into 85 divided by 20. That will give you the 6 kilo ampere. Okay. In the similar manner, the value, just put the value as you have the value of is. Just put the value of is here. You know the value of cos 15 degree and cos 75 degree. You will get the value of ID1 as 4.25 kilo ampere. That is very much amount of current that occurs for this practical operation. Now in the similar pattern, when you write for mu equal to 60 degree, mu to 60 degree means if you write just alpha equal to, then the equation that is ID2 will become, for mu equal to 60 degree becomes is, that is cos 30 degree minus cos 90 degree, that is 30 plus 60, that will give you the value of 90 degree. From there, just put the value in the similar pattern, you will get the value of 5.2 kilo ampere. That means as the value of mu increases, then the value of ID1, ID2 also increases. That means they are correlated with each other, indirectly proportional. Now you can say, with the increment of value of mu, the value of ID current will also increase. Now, what will happen when ID is of 2000 ampere, or you can say ID of 4500 ampere? In that case, the value of ID for 2000 ampere, we will have the mode 1, that is less than 60 degree. Okay, that is range is 4.25, that is higher than 2000, that is closest and higher than that of 2000 ampere. So just put the value of cos, and that is vector VD equal to cos alpha minus vector ID, that will give you alpha equal to 15 degree, minus vector ID is given by ID divided by 2is. So the value of ID is given as 2000 ampere. So 2000 ampere 2is, as you have the value is equal to 6 kilo ampere. So just multiply with the 2, you will get 12 kilo ampere. So putting the value of 12 kilo ampere, you will get this equation. So just putting the value of cos 15 degree and solving this equation, you will get the value of 0.8. This is the vector VD, that is VD upon VD naught. VD upon VD naught, as we know, the value of VD naught is given by 3 root 2 pi upon line current. Okay. Now put the value of 3 root 2 as the line current have the value 85 kilovolt. So this value will become 3 root 2 into 85 divided by pi divided. That will give you the value of 1114.8 kilovolt. So for the value of VD naught, you have the value 0.8. We have the value VD naught value. Just we have to find the value of VD. That is VD equal to 0.8 VD naught. That will give you 91.8 kilovolt. That is the average DC voltage that is flowing in the DC link. So the overlap angle that will flow in the machine or inverter section, we will get by putting the appropriate value. So the value is gaining, that is 35.8 degree. Now this is all about for this ID equal to 2000 ampere. Then what will happen if the value of ID is increased from 2000 ampere to 4500 ampere? Then in that case the mode 2 is active, that is when mu equal to 60 degree. Because in mu equal to 60 degree, when you put the value, that is ID equal to closest to 5.2 kiloampere. So 4500 ampere is quite related with the 5.2 kiloampere. So in the similar pattern, just put the value, you will get the equation and solve it. You will face the value, that is VD equal to, as you can see, this is the elliptical equation. This is the characteristics of the elliptical equation that we have derived in the previous section. That is VD naught divided by cos mu upon 2 whole square plus ID vector divided by sin mu upon 2 whole square equal to 1. So putting the value, you will get VD naught as 0.573, and just we know vector VD equal to VD upon VD naught. So just putting the value, you will get VD equal to 0.573 into VD naught. That will give you 65.8 kilowatt. And in the similar case, as we have the value, that is VD vector equal to cos alpha minus ID vector. Just put the value, just put the appropriate value, you will get alpha or the firing angle as 18.60. So this is the equation, this is the example that we have discussed. In the similar manner, we have the characteristics of the 12 pulse converter. We have till now we have studied the six pulse converter, characteristics of the 6 pulse converter. In the similar manner, we have the characteristics of the 12 pulse converter. Now 12 pulse converter will have the 5 mode. That is first the when valve 4 and 5 will be conduction, start conduction. Then the mode is range from mu have the value of the range from 0 to 30 degree. When for the mode 2, when 5 and 6 volts starts conducting, then the value of mu range lies from 30 degrees to 60 degrees. In the similar manner, when module 3 is involved, or when the 6 volt conduction conducted, then the alpha lies of the value 0 to 30 degree, and the value of mu is your 60 degree. In the similar manner, when valve 6 and 7 starts conducting, the range of mu is 60 degree to 90 degree, and when valve conduction 7 and 8 start conducting, then the range of the value of mu is 90 degree to 120 degree. Okay, so this is the condition, this is the mode of operation of the 12 pulse converter. Now it is written here, as you can see, this is the detailed analysis is given here. So we do not have to discuss this detailed analysis of the converter. Just we can see that it is to be noted that the second mode is a continuation of the first, and similarly fifth in the continuation of the fourth. Okay, the second mode is continuation of the first, and the fifth mode is continuation of the fourth. That is correlated with the bulk. So these are some theoretical concept that we have that is given as here. So if you know the value of the characteristics of the 6 pulse converter, 6 pulse converter, you can easily find the characteristics of the 12 pulse converter. So as you can see, when it is given as the value of k equal to xs upon xs plus xt, where xs is the source reactance and xt is the converter transformer leakage reactance. So in that case, it is written here that it is to be noted that the interaction between the adjacent bridges can be neglected if the converter bus voltage is sinusoidal. Okay, when the converter, this can be affect the shape of the converter characteristics. Okay, this analysis of the converter station, that we should go through the topic, that is analysis of the converter. That is not very much important for the your HVDC system. So this is all about the HVDC system. If you have any problem, then you can ping me on my WhatsApp. Okay. So this is all about today's class. So thank you very much.